Hello and good day to you. You're once again welcome to MES on Construction. So we'll discuss all things engineering, architecture, and 3D modeling. Today, we'll be learning in Protastructure how to design and analyze your ribbed slabs. We've been on this for a while, and in our last lesson, we were able to model and design a ribbed slab, and this is what we had in our tutorial for today. We're going to be learning how to properly design the ribbed slab and also how to analyze the ribbed slabs. But before further ado, we encourage you to subscribe to our channel for more contents like this, and don't forget to turn on your notification bell to be the first to see our latest tutorial videos on Protastructure and how to use Protastructure for your structural engineering design and analysis. Thank you. Now, let's get right into the video. So, before we go on with this, let's touch everything we have done before. Let's revise them again. So, you can click on this, and when we click on this, you see that we have this panel popping up, and this is the panel for our rib slab. And as you can see, the BW, which is the width of the rib beams, is 150. The H is the depth of our rib beams. We can't see that from here. Then the H slab is actually the depth of our slab, and then the S block is the width of the material that is in between each ribs. And you can get that by going to your measure. You can use your measure button to get that. You can see that this S block is 400 here, and when you measure this, you see that it's 400. You can press escape. Then the BW, which is the width of the rib beam, also can also be identified like this. As you can see, it says 150. Whereas in your 3D mode, we can just look through your the depth of our beam. This is the depth of the rib beam. It's going to stop somewhere around here, and whatever remains of it becomes the depth of our slab, which is going to be the H slab, which is when we click on it, which is the H slab, which is 80. I'm going to remove this from my review because the design is expired analysis, so I'm just going to remove that. So now let's go back to our story plan, and I'm still going to click on this. So I don't want slab to contribute to my floor diagram, so I'm just going to click that. uh, Depending on the nature of your project, I believe my slab is quite slender, and I don't want it to contribute to floor diaphragm. So now we need to add a dead load, and we also need to add imposed loads. And as you can see here, we have our self weight to be 5.062 kilonewton per meter square. So we can enter a value for our dead load. So I want it to be rooms. Why, you can also create this customizedly. We don't have a roof load, so I'm just going to enter like 2 for the value of my imposed load. And you can see all the loads that are acting on our rib slab is self weight, then the dead load, and also the imposed load. Then we update this, then we can close this. So now what's next is to draw our slab strips, and there are some things that are very important to note before drawing your slab strips. And one of them is that your slab strips must be drawn in the direction of your rib. And also, there are different ways to draw slab strips on your rib slab. The more accurate way is to draw each slab strip on each rib. Uh, that will give you a more accurate result, analyzing each rib individually. Whereas you could also choose to draw a single slab strip on the area you find to be most critical, which we consider the rib around that region, and then use the rib around that region as a standard to calculate other ribs. So what I'm going to do in this tutorial today is I'm going to just be drawing a single strip, and this single strip will act as the strip along the critical rib, and it will be a standard to which other ribs will be designed. So let's get right to it. Let's go back to our modeling, then let's click on slab strip. And once this comes up, other things to notice that you need to change this to FE strip, and then the direction is also very quintessential. You have this to be drawn in a X direction, so we're going to be drawing a strip in X direction. And the reason why the direction is actually very important is that if you draw in a very wrong direction, if you draw in the wrong direction, you're going to be having problems with your axial load comparison report, and it's going to let you know that something is wrong with your slab strips. So if it's also drawn like this, then you have to take the direction of Y strips. So we're going to be taking the direction of hex strip right now. Also, we will consider the the end conditions, and as we have learned before, this is slab to slab, this is beam to beam, this is cantilever to cantilever, and you can also have them traversing like beam to slab or beam to cantilever and all that. But in this case, we have beam to beam, and we're going to be leaving it as default as it is. And then we have to go to FE as well to go and click on rib slab to select rib slab right here, because if you don't do that, it's not going to give you the accurate result, because we are dealing with rib slab. We have to click this. So we go back here, and then we can update. You may not choose to update. So now we want to draw a rib across the midsection, and don't forget to press your control to have a very straight line going through, and then we can insert a strip right there. And once we have our strip drawn and all our parameters here properly set, we can close this. So now what is next is for us to go ahead to do a load decomposition. So let's decompose our loads. As you can see, the loads are not properly decomposed yet, so we want to decompose them. So we press continue and wait a little bit for it to calculate. Yes, and we can press OK here. These are things that we've been through before. So, and once we press OK and it's done, we can close this. So it says apply to selected beams, apply to all beams in story. Now I'm choosing this apply to all beams in model. So, but in your own case, depending on the nature of your project, you may, just look to know which option suits you best. So now we have decomposed this. We've already done our load cases and all that before all this. So we can now proceed into performing a floor analysis on this ribbed slab. So let's go into our analysis tab and perform a flow analysis. Before performing flow analysis, you may want to, select your bars in building analysis, to know which bar you'll be using, for which structural member. So that can be done in pre-analysis. You edit materials. You see your concrete columns, what you want, the Rebar diameter of your concrete columns, also the grade of your steel, and also the grade of your concrete. So here I'm setting all my columns to 16. In your own case, it may be different. So you can just simply, from all the random selections, it does select by default. You can unselect or select all. Then you pick the ones that you want and press OK. Also, I have my concrete beams also to be, Y16. And I also have my normal slab to be 12. Here we don't have a normal slab. We are not dealing with a normal slab. We are dealing with rib slab, and my rib slab, the Rebar diameter constitution is 10. So, and as you can see, I clicked on that here, and that's what's going to design for me. Then for my links for the columns and for the beams, I have 10 because I'm using 16. So now I can close this, since I've set all the parameters for my materials. Then here also you have unit weight of member, unit weight of blocks, and coefficient of thermal expansion. So these are things that you just set up. Then project parameters also, you can set that up depending on what is applicable to your project. So now we can close this and go to our floor analysis. So our floor analysis, we're setting the stiffness factor for the slab to be slightly lower than for the beam and the columns. That's 0.25. And we're also taking all these include slab plating FE model, consider beam torsional stiffness, then include upper stories. We don't have any upper stories, so I could decide to take this up, but I'm going to leave it as default. So, and we are also considering for the column wall type short frame model, even though we don't have any wall in our design. So I'm just going to go here, to perform the analysis, and also you can see that my slab stiffness factor here is set to 0.25. So I'm going to press OK here to design, and wait a little bit for it to calculate. And once the analysis is complete, it will bring up this set process complete, and you can see story 1. You see maximum positive moment, you have maximum negative moment in millimeters, minus 2.843896, which is okay for me. Now I'll have to go into floor mesh analysis to check what I have. So it says for FE model exists for this floor. Do you want to replace it? Yes, I want to replace it. In your own case, if you have not designed anything before, it may not bring up this pop-up, but this one is coming up because I already have a FE model for this floor. I initially designed something, so that's why it's popping up. So I'll press yes. So now I have this right here, you know. So I have my model right here, and this is what it looks like. So, but I'll not be taking too much time looking into this. I'm just going to close this immediately, and then wait a little bit for the analysis to run its course, and then bring me to post analysis process and reports. So here is where you check whether your direction is good or your direction is terrible, and your calculations are erroneous with your axial load comparison report. Even though we don't have building analysis reports yet, that's why it's coming up with this dialog. Analysis status is not valid. The building analysis. Do you still want to create the report? I say yes, and you can see because we have everything okay, our report is not going to be coming with warnings and all that. And you can see we don't have any warnings here, even though we don't have a building analysis, yet done. Even though in this case, what it's doing is that it's using the old building analysis that I did. But if you have not done any building analysis, it will still come out, but there won't be probably building analysis, to compare with. So, but to come out okay. Let me close this and let's go to our analysis post processing. So now in our analysis post processing, you can scroll to get this out and make it visible. And then you can see the deflections, and then you have here all our load cases. Then you also have the load combinations, the dead and life load here. Then all the effects that are acting on our structure, on our rib slab. You have all of them here, the area of steel, required area of steel and all that. So what I'm going to do here, you can play this animation if it gives you some satisfaction to just see how, you know, it deflects or it displaces. And you can go on ahead to close this. Then I will include or consider plate torsion effects with an hammer and slab design moments. I'm going to do that, and I want to include in strip results, column and wall results transfer options. So I'm going to press OK here, and then I can close this. So now I've analyzed all the components of my rib slab. Now what is left is to go and manually design what I have, analyzed. And in order to do that, I need to go into rib slab here. This is the rib slab for the strip that I drew. I drew just one strip, so I have this right here. I can click on this and go to design. And when I go to design, I'll just go to rib beams. As you can see that this is not yet properly designed, even though I've analyzed it, it's not designed yet. So what I need to do now is to design. So I can just go to interactive design, and because I've set all my parameters properly, it automatically designs it for me, and it says I'm going to be using 2y10 for the top bar and also 2y10 for the bottom bar. I could decide to remove this cranking, and I could leave it. So, and I can press OK, and once I press OK, you see that it's now properly designed, and it's designed okay. So I can close that, and after closing that, I come back here, and as you can see, we have designed a ribbed slab. Now what is left for us is our columns and our beams. As you can see right here, it's marked red, and we can also design that by going to perform our building analysis, and also for the ribs as well. So I go to analysis, I go to building analysis, and in building analysis, we have touched on editing our materials, so we don't need to go through that again. So I'm just going to close this. So the model options, we don't want any rigid zones. So, and when we go to shear wall, we don't have a shear wall though. So you can skip this and go right straight into slab model. We want slabs to define rigid diaphragm. Then you have to click finite element mesh and include slab in building model. Then also use decompose slab and rib loads in mesh stories. Then stories to be meshed, you click. In this case, I only have this story one, so and it's clicked. So I can go to settings also, leave all this as default, and I use the composed beam loads. Then I think I'm good. I can go to building model check. I go to analysis and I do a building model check. Check if my building has any modeling error, and it says number of errors is equal to zero, and so I can close that and go ahead to perform my building analysis. So I'm not really designing anything right here. I just want to perform an analysis. So I'm going to just perform the building analysis. I want to design my beams and columns manually. So it says relative storage drift satisfies the limit in direction one and also in direction two. So I press OK. Then I have my analytical model behind here, so I can close this. Then first, before I go to my analytical model, I want to check out my Asia load comparison report again, and I see that everything, you can see that everything is okay here. We don't have any pop-up notification here telling us that something is wrong. So, and we can easily just close this. So we can also close this. And then we have this analytical model here. You can click on displacement and also play the animation, and as you can see, for dead load our maximum displacement is 1.66, for our live load is 0.4, which seems okay. Then the combination of our dead and live load is 2.97 millimeters. Everything is in millimeters, and I think this is okay. Even though this is a small project, for bigger projects, you may need to make some adjustments to make your design to work even better. So I'm going to stop this, and then I'm going to take this off. I want to go back to my story plan, and then when I go back here, you see I don't have them designed. I don't have them designed, the columns and the beams. So I can actually choose to design them here by clicking on them, and design the section individually, or I could just simply go back to my building analysis and go to post analysis and then design them all at once. So since I have everything going well, because this has been designed before, and I have 4x16 for all the bars, so I can just click on this and then press OK, and you can see that pops up with a green icon, and then OK, same thing here, and then OK, the same thing here, and then press OK. So we have all that done. This is a simple structure, so there's nothing much to worry about. So we have 4x16 bars, and the lengths are y10 at 175 spacing. So we have that. Then we can go to our beams as well and do the same. So you can press interactive section. As you can see, it's well designed. There you have 2y16 for the top bar, 3y16 for the bottom bar, and everything looks good. So and you can see we have nothing designated right here, so everything is okay. You can press OK, even though this design status may not change, and this is because it's the whole design I have done that is in play, and the whole design is not actually wrong. That's why you see it's marked instead of marked with cross. So but in order to make this to become green, what I just need to do is to make the software to believe that I've changed something, but what I changed still doesn't undermine the integrity of the result. So when I press OK now, you see that it's marks green. So I'm going to repeat the same thing for the remaining and press OK. So I see everything now is marked green. So I can now close this. I can close this now, and I can also close this now. So I have everything here designed, and you don't have to bother yourself about what is here, because this is just this is symbolizing that whatever we have designed here is still the old thing that we have there initially. And because I've actually worked on this project before doing a tutorial on it, that's why I have that. So, but if you want to check if your design status is very okay, you can go back to your review, and in your review you click on design status, and as you can see, our design status marks structural members green, and this means that they are okay according to the legend. So which means that the design of your columns and the design of your beams, they're okay. Usually this design status doesn't work on this version of Protastructure for ribbed beams, but notwithstanding, your ribbed beams are okay by going to, let's go to design and let's go to ribbed beams, and you can see that it's marked okay here. So you can also check, go to slab analysis and design. Then instead of going to normal slab analysis and design, this is for normal slab, this is for ribbed slab. So you have to go to this, and you can click on all stories. You can just click on the present story. So but I just decided to click on all stories. So you design this, and then it comes up. So in this case, what it does is that it only designs for the single strip that we drew, and a replication of what is designed for this single strip is what will be used for all the ripped beams. So as you can see, you have the G to be 5 point. That's the dead load. The self weight of the ripped beam to be 5.062. Sorry, the self weight of the slab to be 5.062, and we also have the additional, you know, dead load to be 2.375 for a room, and then the live load to be 2.0, kilonewton per meter square. And you have the calculation done right here, and you have the support moment. You also have the shear forces and also the span moment right here, and everything is okay for this. So we can close this, and then you can close this also. And then there's one additional thing I would like us to do. When we go to the story to the rib beams, you can see that in these rib beams you have, the quantity of ribs to be 9, and this is, you can actually increase this or reduce this, because if you are interested in designing the ribs individually, then it means that, just as we stated earlier, you need more strips, to draw more strips over your rib beams. But in this case, we just drew one strip over all, assuming that particular section is the most critical aspect of our slab. So that's why we are using the design, replicating the design for the closest rib to that strip to, you know, be the design for all other strips. And as you can see here, it's labeled quantity. This stands for the quantity of the rib beams that we have. And when you go back to count, how many rib beams we have, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, which means there are 9. So you could remove and decide to, design a particular rib separately, and you also have calculations coming out, and you also have you know, the design coming out separately. Instead of you having X1, you have X2, and it's also come with its own individual design. So that's just it. The last thing I want us to touch on is actually to look into the reports, join and reports. And in our join and reports, we can go to our rib beams, and you can click OK here, just to check what are, the detail of our ripped things. And as you can see here, you have 150 here, you have 150 here, and the total section is actually 400, as we have designed for the depth of the rib beam. And as you can see here, you have 2Y10 for the top reinforcement, and also 2Y10 for the bottom reinforcement. And then you have a cover of around 50 for the top and the bottom. And you can see the 2Y10 for the top designated and the bottom designated here. So this is the detailed design of the rib beam, and this is the detailed design of the rib beam. So now you can also check the detailed design of your normal beam of the story beam elevation, and you can check that also. As you can see, we have 300 by 600 is the section, and you have 2Y16 for the top and 3Y16 for the bottom, and then you have this to be the depth of your slab. As you can see, the each slab, this is the depth of the slab, 80, as you can see right here. I believe this brings us to the end of our tutorial for today on how to design and analyze rib slabs. So we encourage you to subscribe to our channel for more contents like this, and don't forget to turn on your notification bell to be the first to see our latest tutorial videos on how to use Protastructure for your structural engineering design and analysis. Thanks for watching, and bye for now.